So now that you've seen how to add a background and some actors to a world, we're going to put some behavior in. And the overall goal is going to be that we learn about building classes, but that's a process. It's not going to happen just in this one video. So throughout the course of these, you're going to have a better understanding of how classes put things together. So let's just get started here by creating the world. We're going to use the ocean that we had created in the last video. And I remember that this was a 900 by 500 pixel image, so I am going to match that up so that the image displays without being cropped anywhere. Now, I've planned to build a game with you over this series so that you can see, the basics of a simple game and hopefully give you some chance to dream up your own. Now, the one that I'm going to be building is going to be a shark that goes around eating fish and getting points for that. And the villain in this case is going to be a submarine that's dropping some torpedoes. So the first thing I want to do is show you the torpedo class. Now, I've put a lot of thought into trying to build the back end of this that you're not seeing in the video. But anyways, we'll be building from the bottom up, starting with a simpler class like the torpedo. And I've gone and got my image already. So I can just give you an idea of what it's going to be like. There's my torpedo. And there's no behavior, so when we run, nothing happens. But I can go and change that. Now, one thing I want to show you is how Greenfoot initializes things. So inside the act method, that defines the code for how the actor will act. So in here, I'll compile it, and it's going to move 1. It's not going to do what you think, because the torpedo, the way it's set up here, visually it's not the same way that Greenfoot sees it. So the way the torpedo is facing, you'd expect it to start falling once I hit run, but it's actually going to move to the right. Now, why is that? Well, everything in Greenfoot that comes in is initialized to 0 degrees, and here's how Greenfoot sees the 360 degrees something could be facing. So 0 degrees is facing this way, which would be east to us, and we want the torpedo to be facing 90 degrees to the south. That way it's falling in this direction, because if you remember the move method, it's in the actor class, and if we call on move, it says the direction it's currently facing. Okay, so if we go into the torpedo class and we just say, aha, I need to turn this, one way I can do it is with a set rotation method. So I'll set its rotation to south and then move it. Well, this is also going to give us some funny behavior, because as soon as I hit act, what's going to happen is it is going to rotate that object 90 degrees, so it's pointing south, but it's from the current position. So it's falling, but the torpedo is actually the wrong way. So the problem here can be fixed in several ways. First, what we could do is, rather than have the image pointing down like this, in my image editing software, I could have it line up to Greenfoot, which means it'd be facing this way in the image editing software, or facing 0 degrees, so that I know the torpedo is initialized in the same direction that Greenfoot does. The other way we can do it is just to change the behavior of the way things move. So let me show you how we can do that. That's the solution we're going to use here. It is a very simple class. All I want my torpedo to do is fall when it runs. So it's basically going to fall to the bottom of the screen. So let's go into the editor here and I'll show you how we can change this. So this is the first thing new in a class that you haven't seen before, and this is called a method. So in Java, you've already been working with the main class, but now I'm going to show you how to break your code up. You can kind of think about it like paragraphs. It helps organize your thinking into small chunks, so it's much easier to code big projects because you're only thinking about it maybe 10-20 lines of code at a time. The trick to getting good at it is how you pick those 10-20 lines of code and how you divide things up. So here the first method that we're going to take a look at is how the torpedo moves. So here's my method, and it's going to be the move method. And it takes in an integer that I'm calling distance. So let me explain to you the way this method works. So this is the access that the method will give to somebody. Public access means anyone can use this. It can be called from anywhere outside of this class. There is another way of giving access, which is private, which means that nobody can access this except when they're within the torpedo class here. So this would be usually what we call a helper function, something that is again another task that's broken down, but it's not useful to anyone outside the torpedo class. So we want it to be public because we are going to call it from the outside when the world tells them all to act. And the next thing here is the return type. So this is what Java will give back to the person who asked for the move method. Now, maybe one of the easiest ways we could give you an example here is if you had a string like this, and I said my string index of s, this method returns the index where it finds s, and that's an integer. So how does Java know this? Well, in the method, the return type here would be an int. Then Java knows that when someone is calling on that method, that they have to reserve space in the computer for an integer. So that's why you have to declare it ahead of time here, so Java knows what's coming back to the person who's using it, as well as what kind of memory it needs to put aside for it. When there is no return type and all we're doing is just performing some actions, we call those methods void, meaning there is no return type. So the torpedo's behavior is that all I want it to do is fall down through the screen. I don't want anything fancy, it's just going to keep dropping. Now, the way I'm going to do that is I'm not going to use the move method that was provided. I'm actually going to rewrite it here. And what's happening behind the scenes is a method called setLocation. So another way you can move here is you can use the setLocation method. So let me explain to you how setLocation works. So if we were to zoom in on Greenfoot, you would see a grid, and here's the grid that we've created. Now the grid is zero based, so this would be x equals 0, then x equals 1, x equals 2, and so on. So 3, 4, 5, 6, 7, 8. But when we're using y, now when we travel south, y actually increases. So this would be y equals 0, still zero based, but I'm actually increasing as I go down. This is not unique to Greenfoot. It's actually the standard that you'll find in just about every graphics library, that x increases to the right and that y increases as it moves down. So if we wanted to say locate what's the coordinates here, that would be 0, 1, 2, 3, 4, so x equals 4, and the y coordinate would be 0, 1, 2, 3. So when you're mapping your locations in Greenfoot, that's how you're doing it. It's zero based, and y is increasing as we move down. Okay. So that's ultimately what we want to do, is change the location. And to give it the appearance that it's falling, we want to drop that location or add 1 to that y. So here's the methods that get the current location for x and y, and that's what we're going to use to figure out how to move 1 down from there. So in here, I'll go x is get x, and y is get y. Now I have the current location, and I'm just going to call setLocation wherever I was, and then y plus however far I'm supposed to move, so distance. So all this method will do then is it will take where I used to be and move me down that many spaces in the grid. So we can update our act method now. Now when we call move, instead of doing the move method from the actor, it's now going to be overwritten by this move method that I gave it. And that's the way this works in a class, is when you extend from another object, actor is what you get for free. If I was to go here, all of these methods are now shared to me. Everything in here I get because I inherit them from the actor. So as a torpedo, I can call on any of those methods and reuse them. However, if I want to give my own specific way of behaving, all I have to do is overwrite it by using the same method, but defining my code in here. So there's the same method signature, and that's what we call it as programmers, the method signature, but now I'm telling Java how it behaves differently. And that's the same thing that ACT is doing, is ACT is saying, this is the signature that all actors have, and I will tell you how my torpedo is going to act. So the way a signature works is it's the name and the parameter types here that you have. So you couldn't rewrite it like this. You couldn't have another method that went move int x. So even though it looks different to you, Java can't distinguish those, because when you call move1, all you're doing is calling move with an integer, which is this one here. So there's a couple ways you could get around it. One is to use a different type of parameter. Now I have a different signature. Or I could use more parameters. That would move me, and Java can recognize the difference because there'll be two integers. Maybe one's an integer and one's a string. So as long as Java can distinguish between the name and the parameter types, you can keep reusing that method name. And of course, if you wanted to change it, you could call it int distance, and we could call this like move 2. You know, it's not a very good name, but Java can distinguish move 2 from move. So it would know the difference between me using that and that. So when you name your methods, you have to obey those rules. Your signature has to overwrite the one in the actor class. So how do you know that you've overwritten it? It has the same signature. And if you're wondering about the variable name, that part doesn't matter. The fact that it says distance here, it will still work if I just called it d instead of distance. But in order for me to overwrite the actor's move method, I have to show that I'm using the same signature. So Java says, that's the exact same method that the actor has, so the torpedo is defining a new move method. Okay, so let's go and see what happened now when we take a look. We'll put a torpedo in. Now when I run it, it's doing what I want, which is falling. Now there's one problem here, and you're going to see it in a second. And that's the torpedo stops here. So the problem with that is, if you imagine me having many, many torpedoes, it's going to start to clutter up this screen. And we don't want to do that. We'd like it to look nice. So I'm going to program the behavior of it so that when it hits the edge of the screen, that I take it out of the world. So let's go back into the code. And again, I've said a lot of things in there, and you could just go cranking the code out here. But the ACT method itself has a lot of problem solving happening and methods and other things being called. The more code you complicate it with, the harder it's going to be to track it and extend it or look for errors. There's all kinds of reasons why you want to always maintain nice, neat, small methods so they're easy to follow. And that's what I'm going to do here. Is I'm not going to put the code there yet. One of the things I said is I wanted to know if it will go off the grid. So I'm going to make a method called canMove. And you give me the distance, and I'll tell you if this torpedo can move. So this signature is going to be called with canMove, and I will give it the distance it's going to move, and we'll figure out here if that's true or not. And since I'm returning true or false, that's why I know my return type is a Boolean, and it's public access because I don't mind anyone who wants to use this can. So what I'm going to do here is say get the coordinates that I had here, and I'm going to see that it doesn't go out of bounds. So if you remember when we looked at the ocean, it was 900 by 500. So I know I have 500 cells of height in the grid. So that's what I need to be able to figure out. So one solution we could do is I could go like this and say, let's get the y coordinate, and we will return that the y coordinate that I'm at plus the distance that I want to move has to be less than 500. The reason it can't equal 500 is because it's zero based. There's 1, 2, 3, 4, 5 cells here. However, this would be y equals 3, and this would be y equals 4. Because it's zero based, it's off by 1. So that's what I'm doing here by saying it can't be equal to 500. Now, hopefully by now with programming for a bit, you don't like the fact that you see a 500 here. First of all, it's confusing. What does that 500 mean? If you're not the person who wrote it, you probably don't know why it's 500. It's also not very versatile. If you decide to change your game and you end up changing the size of the screen, I mean, that's very reasonable to say maybe you want to change it, then you're not going to end up being able to do that without causing an error here and this code not working the way you intend it. And this kind of error is a sneaky one because it'll compile fine, but it won't run the way you want it to. So what we're going to do is we're going to be a little smarter about it, and we're going to ask the torpedo class to get the world for us. So each actor can go and ask itself for the world, and that's the actor the world lives in. And then we can ask things of that world and say, query certain properties or what's happening in the world at that time. So I'll say get world. And now what I want to do is I don't want to use 500. There's a method inside the world that can get the width, or in our case, get the height, the number of cells for the height of the world. That's what I want, so I don't have to hard code it. So this would be world.getHeight. And now, no matter what happens to the world, this method should return true or false the way we intend it to. So here, I'm going to update this now, make it look a little nicer even still. So I'm going to say the distance I'm moving equals 1, and if I can move that distance, then move. Otherwise, the only reason it gets here is it would go off screen. So at this point we know we want to pull the torpedo. We don't want it to appear anymore. So again, if we go and we find out what can we do in the world here, one of them is remove an object. So if I want to remove it from the world, that's where it's going to go, is if it's going to go off screen, I need to get that from the world. So let's say world W is get the world, and w.remove object. Now, here's the kind of strange part. You might be thinking, how am I going to say what I'm supposed to remove because I'm still building it? And Java's figured out the solution to this, and it's to use a keyword called this. It means remove this object, the one that I'm working on, this thing that I'm building, the torpedo that I'm currently executing the code for. That's how you refer to it in Java, is I'm building it, remove it. So anytime you want to refer to the object itself, you can say this. Now, you can use it anywhere it makes sense, but you could also say this.move, because it'll say this torpedo, and it'll go down to its move method, which is here, and it'll execute the same code that we intended for it to do right there. I also see that I should have gotten rid of that and had moved by the same distance. Again, I want to get rid of that magic number because the distance I'm checking is here. So if it can move that far, then I'm only going to allow it to move the same amount. Before, obviously, I would have had problems there if I would have changed that number. Okay, so just to recap, the act method is all it's doing is deciding if I can move, then allow it to move. Otherwise, remove it. It's been taken off the world. And I created a couple methods to help me with that code. So everything is trying to keep it very small, compact, and simple. Although the whole project I'm aware of, when I'm coding, I'm only coding the method at a time. So I'm only having to think about how to write this one move method. And I'm only having to think about how to write this one can move method. So the simplicity there is what we're shooting for, and that's why we try to write these extra methods. Okay, so let's just take a look at the updated code now for a torpedo. We'll compile it, and I'll add one, and hopefully now when it hits the bottom of the screen, it's going to disappear. There we go. Okay, so we're almost done adding the behavior of the torpedo. There's one other thing that I'm not sure if you can guess, but the last thing I want to do is I want to know if the torpedo hit anything. So anything the torpedo hits, I'm going to end up, geez, I hate to even say killing it, but we're going to end up simulating that by removing that from the grid. It'll end up getting taken out. So it could be that, as I mentioned, I'm making a game with a shark. It could be that it's the shark that got killed from it. Or it could be that there's something in the way, like in my game there's fish, then those fish also would be destroyed. So the shark to get there before the torpedo does. To manage this, we need to know if two shapes have collided. And in order to do collisions, we can go into the actors method and we can ask about intersecting objects. So if something's intersecting the object, like myself right now, if something is run into the torpedo, then this method will end up getting it for me. This gets one intersecting object, which is all we can deal with for now. And of course, I'm going to show you techniques so that way you're able to get all intersecting objects so that you can process all of them. For example, there may be more than one object there at a time. You may need to shoot or destroy whatever it is to many things. But for simplicity, we're just going to deal with one right now. Okay, so that's the other thing we're going to add to this behavior. If you think about the words I was using, one thing that can help you determine whether you should write a method is if you were to write out these things in English, the verbs tend to tell you what you're doing. Like I was saying, can I move? And I will move the object. I want to remove the object. And right now I'm saying they've collided. So maybe I'll make a new method, public boolean collides. And all I want to know is this torpedo hitting something? So the way you get that is we use that method. Maybe I'll copy and paste it. And you have to tell Java what class you're looking for. So I could do something like get me all the torpedoes that intersect with this object. Or I could say get me all of the, eventually we're going to write the fish class. But in this case, the torpedo is the supreme object, I guess. It will destroy anything in its path. And the way you get all objects is you use null, which is the key word to say there is nothing here. So Greenfoot assumes that by saying get me the intersecting objects of type nothing, that you mean give me them all. You're not making a distinction in the type of object, so it gives you all of them. Okay, now that I have it, it's stored as an actor. I don't know what kind of actor it is, but I can still access all of the methods that an actor has. You'll see later that we can try and figure out at runtime what kind of an object it is, but you could also cast it if you knew what type. So if you knew that you were getting a torpedo, you would use casting just like we've already learned about, and then you could use this as a torpedo instead of an actor. But for now, we don't need that extra behavior. It is there though. We will just get the actor. And if it collides, that means somebody is there, meaning they're not null. So that's what I want to do, is I'm going to return that A is not null. So you can test it. If it was equal to null, then you know no one was there, meaning it didn't collide. So you could also do something like not A is null. But anyways, this will do it in one operator, so I might as well go that way. And one thing I see students do early, like when they're doing this kind of method, is sometimes they like to do things like if A is null, then they return the object here, saying, oh, it was null, so it didn't collide with anything, else, and then they'd say return true. But if you're already returning a Boolean value, then generally you don't need to use the value and then return true or return false specifically. You can just do what I did here and actually return the condition. So Java will evaluate that to true or false for you. And then you get back the answer you're looking for without having to do that decision block. So of course that's also one other way to make your code run a little faster. So now I'll know if it collides. And if it collides, I actually want to destroy what was there. So let's call it destroy. And there's, we could make a combination here of these methods, but I'm just trying to give you the point right now that you can split up the tasks. It probably would be appropriate at some point in here to just allow it to be like, some kind of method like collide and destroy or something as a combination. But anyway, so this time for destroy, it's going to be a void. And when we write methods, another thing that we usually do with other programmers is we leave comments. And there's actually a full set of Java documentation. You can see it here. There's actually a language for defining comments, and that's how Java doc gets created. When you see all those, when you Google and you end up with the same, like this format. It's the same no matter what Java you're running it on. It builds the same nice, neat format to find things. We will talk about how to write your code so that you can take advantage of that. But when you write a method, one important thing you include is preconditions. And these are things that a programmer would have to know in order to use your method properly. So destroy is not going to work unless something is colliding. So the precondition I'm going to give is this torpedo is colliding with at least one other object. Okay, because what I'm going to do is I'm going to get the object again, and I'm going to remove it from the world. So let's get the world, and then I'll say w.removeObject, the actor. And the reason I need to know this ahead of time is if it returned null, meaning no one was intersecting, and I tried to remove null, then I might end up crashing the program. So that's why a programmer who is using this would want to know about the precondition in that method. And again, we will talk about writing up your classes with proper Java documentation, but we've just started, and for today, I want you to see the structure of how to write these methods and program a bit of behavior to your actors. Okay, so now I've got a torpedo that falls, and it removes things if it goes off the screen, and it also destroys things that it collides with. So in here, if I think about what's happened, the torpedo has just moved. So here's where I want to make sure that something has collided. So I'll go if it collides, then I know I need to destroy whatever it hit. So if you think about the sequence of actions, it wouldn't make sense to put it here because it just got removed from the screen. So if it got removed, then it doesn't make sense. It's not going to collide into anything or destroy anything. And that situation might still happen if I was to put that block over here like this. That behavior wouldn't work because what I might end up doing is I might end up removing myself here, but then trying to use myself again after it's been removed, which again will crash. So the appropriate place is where we had it, and it's the sequence of events that you'd expect. If I can move, and I do move, then I need to check, did I hit somebody? If I did hit them, destroy them. So that's just the flow of the code, but it has to, sorry, the flow of the game, but the code has to match that in order for the game to run properly. Okay, so let's just see if that's working now. Compiled, and we'll pull that up. You'll notice we do a lot of testing each time we do a method. It's kind of handy to keep your thoughts going. Here it should stop and disappear. Beauty. Another way you can test them, I only have one other actor here, but I could in the future put something else there to test. But what I'm going to do is make them just about ready to collide. So I'll put it right about there. And now all I'm going to do is I can call the act method on just one. These ones here, these are all the methods we put in that belong just to the torpedo class. If I want to inherit from the actor, these are all the ones that I can call, as I said, that I didn't need to define, but the parent class has done for me. And Greenfoot's kind of nice. It tells you here it's been redefined. So even if you call move here, you probably don't want to use the one from actor. You're going to want to use the one that we have. So let's see what happens when I call the torpedo's act method. Oh, it's going to be slow because it's only moving one pixel at a time. But anyways, it's close. Boom, there it hit the torpedo. So now this one would keep moving. So whatever object I put in, that torpedo is going to destroy it. The reason I couldn't do it with two and act is they'll both be falling. So if this one's here, when I run it, they both fall. So one will disappear off the screen and then the other one, so you didn't actually see them remove. That's why I had to set it up the way I did before. So that's a lot there that we've just covered. We really went into the deep end here as far as your first introduction to how you can program behavior, as well as creating methods and classes. So the important thing is not so much the behavior that we added to this torpedo class, but it gives you an idea of what methods are already available in the actor class and in Greenfoot, some of the things you can do. As well, it shows you the structure that you should be using. One where you're avoiding long methods. You're trying to keep your code to something reasonable like 10 or 20 lines. in each one of these methods. Sometimes you can avoid it, but obviously, for reasons I've already discussed, you really want to strive to keep your methods compact and very simple to write and read. For example, if I knew there was a problem that it wasn't pulling it off the screen, like it was supposed to destroy something and it didn't, then I know I can go right to this one little block of code and re-examine it. If it was all written inside this block, it would be harder for me to find the starting point, and I would also have to debug through all these lines of code. Now I only have to look here and debug through 3 lines of code. So for today, again, my hope is that you feel like you could at least program some behavior, maybe not the exact same one I did, using your Java doc and some of the methods given, as well as create your own method now that you can call so that you can break up your code.